In the previous video lesson, we discussed the integration by substitution with the help of an example, and now I'm going to tell you the theory, what was hidden behind this. We had an integral, let's say I equals to indefinite integration of f of x with respect to dx, just like here we had a function, and as we discussed in the previous video that whenever we're going to integrate by the method of substitution, then we have to follow the 6 steps, 1 2 3 4 5 6. So the same thing I'm going to show you theoretically. All right, so first step is taking a look on the variable, independent variable. So here our independent variable is x. All right, we figured out, and that's our first step. And our second step is here replacing our variable, replacing our independent variable with certain new function, with some new function. So our second step is replacing this our independent variable with new function. Let's say our new function is g of t, and that's equals to x. All right, and our third step is differentiating the new function in such a way that we can replace this dx, with which we're going to integrate the whole our question. So we need to replace this dx. Similarly here also we need to replace this dx, so we need to differentiate it. So differentiation of gt will be g prime t, and it is dx over dt. And the fourth step is get a relationship, a good relationship to replace the dx. So from here I can say dx is equals to g prime of t times dt. Okay, we got a good relationship as well. So we finished the fourth step, and now let's go to the fifth step. What is our fifth step? Our fifth step is replacing all the variable with a new function. New function is of t. So here our question is with variables, so we need to replace these all variables with the new things by using, this was our third step, this was our fourth step, and our fifth step is replacing all this, so replacing f of x. And what is x? X is g of t, all right, and then times dx, and dx is here g prime of t dt. So that's our solution. Then sixth step and fifth step is here the same thing. So integration is always keep in mind by the substitution method. F of g of t times g prime of t times dt, and this change in variable formula is really very important. It's a very important tool. This is going to help a lot to solve the integration problems using substitution method, and it's very important to know what thing we need to suppose, and always we try to suppose that thing whose derivative is already present here. All right, so like we supposed here gt in such a way that our derivative should be present already here, like gt's derivative is present there, then it's very fine. So let's say f is the function of these things, then suppose this as a t whose derivative should be already present here. Let me show you some example, like let's say I need to integrate. Let's say I have here 2x times cosine of x square plus 5 dx. So in this case what you will suppose? It's very clear, because if you suppose this x square plus 5, your derivative is going to be 2x, and 2x is already present here, so it means you need to take t as a x square plus 5. Similarly, let's say you have another question, something like this. Let's say sine x cosine of x dx. In this case what you will suppose? Let's say you can suppose anything. Either you can suppose t equals to sine x, all right, because derivative of sine x is already present here, or if you want, then you can suppose t equals to cosine of x also, because derivative of t, it means derivative of cosine is already present here. So in this case you can suppose anyone. Similarly, let me give you some algebraic type of, let's say you have here, let's say 5x 9 times, let's say log let's say x to the power 10 plus 39, all right, times dx. Now in this case you tell me what you will suppose. You'll suppose x to the power 9 as a t, or you'll suppose this as a t. If you suppose this as a t, then you'll get 9 times x to the power 8. That's your derivative, which is not present here. And if you suppose this as a t, then your derivative is going, 39 is a constant, that it will be 0, and it will be 10 times x to the power 9. All right, so x to the power 9 is already present, and we need 10. 5 is already here, you can multiply by 2, you can divide by 2, so 2 times 5, that's 10. 10 x to the power 9 already present, so it means your derivative is already present here. It means you need to suppose this as a t. A lot of questions we're going to solve more, so that's what I'm saying. You see here, if you're supposing the main core independent variable as a t, then that time you think, you just see there in the question itself that the derivative of that function is already present there or not. If there is already present, then try to suppose that as a new function. All right, try to suppose that as a t or u, whatever you're trying to suppose. That doesn't matter. All right, anything you can suppose. That's not the big issue. So just see whether the derivative of that quantity is already there or not, or we can whether make the derivative present there or not by dividing by some constant, maybe some constant if you divide or multiply in numerator denominator, or by plus and by minus by adding the same quantity, let's say plus x minus x if you're doing, and you're getting the derivative there. So just check out, you do some mathematical tricks, you just apply some mathematical tips or tricks, what do you say, the mathematical tricks, and then whether you are getting the derivative there or not. It is always better if you get the derivative present already in the question. It's always it becomes a very easy and very awesome, while solving you'll feel, because everything will be in your hand, everything will be very easy and comfortable, and very easily in few steps you can get the answer, because the derivative is already present there. You don't have to think more, but sometimes you may have to make a derivative present there by applying mathematical tricks. Keep that in mind. All right, so we'll be talking more, and a lot of questions I'm going to deal based on the substitution method. That will give you more and more confidence, and you'll get a lot of tricks to solve different many varieties of questions based on substitution method. All right, and then we'll be jumping for the next method, that is integration by using partial fraction.